Okay, so sorry for that delay. I want to make some general remarks on analysis and then talk about one of the major tools we use for analysis, which is Tableau. And I'll make some remarks about some additional analysis tools, both for more rigorous sorts of statistical analysis and for graph-based analysis. Broadly, when we're dealing with data drawn from tools like IAPI, we have a variety of, we have a cacophony of numbers that comes out of the system. Many of these are, the data volume is certainly dominated by sensor-based data from accelerometry, data from the GPS sensors, data from Bluetooth or Wi-Fi. It's very large in data, but very large in volume. But we also have data drawn from the EMAs, from the crowdsourced information contributed by people. And in order to make sense of that data, in order to make it meaningful for us in terms of sort of day-to-day understanding, for example, to identify contacts between people, or to identify cases where a person is in a park. And most importantly, to link it up so that we can conduct analyses using it, we have to go through a set of layers of analysis. Kevin emphasized this before. My decomposition is a little bit different from Kevin's, but the general point is there's this almost a stack of different types of analyses that you'll want to perform. Some of them involve simple data cleaning, tossing out values that are clearly nonsensical or due to artifacts of the sensors. There's often some amount of aggregation that goes on. Aggregation so that, for example, rather than just having sort of discrete, fragmented observations that, oh, my phone detects Cheryl's phone, instead, we will aggregate into a 5-minute interval where we will say, I was proximate to Cheryl for some or all of that interval. So rather than going beyond the vagaries of did I observe Cheryl's phone, 27 times or 23 times or just one time, we'll simply make a rule that if I saw Cheryl's phone at all during that interval or over a certain number of times, I will count myself as having been in contact with Cheryl during that interval. There's certain types of simple classification that are often done on the basis of that aggregation, such as I've just talked about. So aggregation is needed over that interval to kind of make possible this classification. Am I in contact with someone? Am I within a geofence? Am I located inside a particular region like a campus? And then there's a more sophisticated classification type of task, which is layered atop of this. And this broadly uses techniques that are variously known as machine learning or computational statistics. One of our partners in this area, Jushin Liu, may be dropping by, but generally the techniques employed here are computationally more sophisticated. They involve processing a large amount of data to try to recognize salient patterns that are indicative of, say, being inside or outside or being in a vehicle or not, that might make use of data from multiple sensor modalities simultaneously. So, for example, inside and outside, it might make use of data from the strength of the GPS signal, the accuracy of that signal particularly, and whether there is a signal at all. If I have a signal but it's very, very inaccurate, it may be an indication that I'm inside a building and there's very little opportunity for it to see a satellite. If there's no GPS readings at all, it may be an indication that I'm deep in the bowels of some large structure. But there might be other indications too. Light levels at night that would indicate that I might be inside. High level of Wi-Fi signal strength might indicate I'm more likely to be inside. And similarly for Bluetooth. Other indicators of whether I'm inside might be related to data from weather. For example, if it's minus 30 outside and it's Saskatchewan and the phone is toasty warm, it's unlikely to be outside. So there's a set of machine learning analyses that cut across particular sensor modalities. They involve many types of sensors to try to form some sort of judgment whether I'm inside and outside. Typically, they will take into account temporal context as well, not merely one data point, but data points before and after, and realizing that there's some continuity. For example, that the question about whether I'm in a vehicle or not can be provided at a given moment, can be provided insight not only from data collected at that moment, but also data from 30 seconds ago, 15 seconds later, because I'm unlikely to be popping in and out of a bus many times a minute. Similarly, in terms of whether the phone is in fact on me or not, similarly whether I'm sitting, standing, or lying down, those are types of behaviors which exhibit a certain temporal continuity. And so you can use data from just a little bit later, a little bit before to kind of to help counter the effects of outliers. There may be certain types of inference mechanisms that are employed, for example, to identify a surface that might be needing swabbing for testing for the presence of pathogen. And then there's a set of dynamic modeling tasks, which I'll be speaking about tomorrow, that involve linking up this sort of data for policy relevant analyses. I want to make a distinction between several sorts of analyses that you will hear about using phone data. These are quite distinctive in terms of the value they bring to the table, in terms of the constraints under which they operate, and in terms of the mechanisms that are required to put them into place. The first of these analyses, I'm actually going to start with the last, will be the one we focus for much of the afternoon on, offline server-side analysis. What I mean by this is the data that was on your phones has been brought back to the mothership. It's sitting on a server, and it may have been collected earlier today. It may have been collected a month ago, a year ago, or several years ago, and I will perform analysis on it. Some of the data Kevin showed earlier from SHED 1, SHED 2, these were studies conducted far back in the day, 5 years ago perhaps, or what have you, and for SHED 1 maybe 4 years ago. In any case, several years back. The point is that the data has been collected, it's sitting on the server, and we are conducting the analysis often in an offline fashion, not in the sense of being connected to the web, but in the sense of being not needing the results to directly influence the user or the phone holder, the participants. There's another type of analysis which involves server-side processing, perhaps in the future in the cloud as we talk about it, being done by sort of functionally similar machines that may be located wherever, but where there's immediate feedback deduced from this that might influence the participants. And there has been one study of this sort we've run, which was a very memorable study. It was called Flu Phone, and it was designed to try to understand the influence of risk perception on people's behavior during an outbreak, a flu outbreak. So how would their behavior change if they were had different levels of information available about the burden of illness within their social network or within the broader community. Here, there is immediate feedback provided from the server back to the phones, not quite in real time. There were some challenges with it because the phone might not be connected for a while, but it would basically update the phones by pushing data to them when those phones connected. Finally, there's a set of analyses that are done on the phone. The phone is actually within its own processing context. It is performing the analysis and using it potentially to call up surveys, to issue notifications, or otherwise to alert the user to some need. So these are three different types of analysis. They have very different trade-offs associated with them. The one we'll be concentrating on today often has access to a lot of computational power, such as the machines you have in front of you. It supports rapid processing. You can crunch the data from multiple phones at once, right? You could analyze on your device information gathered from multiple participants, potentially at different points in time. But the data has to be transported back to the server for this type of analysis to be performed. The data can't be still sitting on a phone that has been out of connection distance for a while. We won't see that data for our analysis. The sort of middle analysis has some of those same needs, but some of those same benefits. This on-phone analysis, by contrast, really has to be done in a power-frugal fashion. It can't be too heavy-duty. And we have to do the processing often very quickly. We're interested in a finding from this analysis that might inform the user, be used to call up a survey in a temporally proximate time to some exposure, such as when they're in the park or when they're in a crowd for an RCT we ran in Michigan. And here, in this case, there's a phone-specific analysis that's conducted. We don't have recourse typically to data from multiple phones. We're operating off the data from this phone. Where are we now? With whom are we associated based on proximity? Has it been a long time since we've exhibited any physical activity? If so, we might undertake an action, but we can't use readily data from another phone, a phone that's, say, nearby, but is distinct. So I'm also going to draw an analysis between what I call, crudely, exploratory analysis, and we're going to be focusing on that with our Tableau work, and then sort of more focused statistical analyses. And we do quite a bit of this in our work, traditionally with R and SAS have been two key tools we've used. I'm going to be talking just and briefly about the use of R and the interface with this sort of data. There's additional tools we use for certain types of analysis. For example, if you're interested in graph data on contact patterns, there's some wonderful tools that are available. Gephi is one of them. In principle, you could take the data from here and export it to PyEC, another social analysis tool, social network analysis tool. There's additional tools as well, like UCINet, or like there's a tool. There was one of the predecessors of Gephi that we've used that's also quite nice. So I wanted to make a few of those additional sort of distinctions from what Kevin mentioned before diving into some of the needs to help you experience interactions with Tableau. So any general questions about this before we fire up Tableau? Yes. Yeah. GEPHI. Yeah, it's an open source project. It's been around for a number of years right now. One of my students contributed to it several years back, and it's a very powerful visualization tool for networks. It's not the only one around, but it's a very very general one, and it can import files from PyEC and other sources, UCINet, etc. Yeah, yeah. Other questions? Okay. So if you folks are up to it, I'd like you to, on your machines, go and, if you haven't logged in, please do. And I'd like you to go find Tableau on those machines and call it up. So TAs, please deploy. There's going to be, the next session will be TA assisted in a central way. Okay? So can you help? Yeah. Help. So who needs TA help to find Tableau on your machines? TA help? Has everyone got Tableau up? The first two rows. Yeah. Sorry. The IT staff had limited time to roll it out. I know the Cheryl corner. That's a familiar one, and it's a favorite of mine too. Okay. So, does everyone else have Tableau up? Okay. So I'm going to stop this and